Hi and hello there, every lover of chemistry, subscribers, and amazing people out there. I'm super excited today to be with you on yet another episode on this series of gas laws that we've been treating thus far. I'm sure it's been an interesting experience for returning subscribers and those of you who are watching for the first time. Trust me, it's going to be a blast for you throughout this video. So today we want to look at the concept of the mole and molar volume of gases. Okay, so let's get into what we have for today's video. First things first, we want to start off by defining what a mole is in terms of gases. Now, to do that, I want you to pay attention to a few words that I've been mentioning. In science, basically, there are words that we use to quantify certain measures. For instance, when I say a dozen, I'm simply referring to 12 pieces of something. It doesn't matter whether it's a basket of apples, a bunch of pencils. When I say a dozen pencils, I'm referring to 12 pencils. When I say a dozen apples, I'm referring to 12 apples. In the same way, whenever we use the word mole in chemistry, we are referring to 6.022 multiplied by 10 raised to power 23 particles. And that is given to us by the Avogadro's number. That is where the concept of the mole comes in. And when we are talking about gases, there is another important idea you need to have at the back of your mind. You need to know that it occupies 6.022 times 10 raised to power 23 particles. And you also need to know that 1 mole of any gas at standard temperature and pressure, that is what STP means, and we're going to get into that shortly, occupies 22.4 liters of space. Now, here is what we mean. Let's proceed into the next thing. STP, by the way, means standard temperature and pressure. S here stands for standard, T here stands for temperature, and P stands for pressure. So temperature, whenever we say STP, standard temperature and pressure, we are referring to 0 degrees Celsius or 273 degree Kelvin. And pressure, on the other hand, when it is standard, we are referring to 1 atmosphere or 101.3 kilopascals. So whenever you hear people say, okay, a gas at STP, STP simply means standard temperature and pressure. The conditions that surround that terminology means that its temperature is 273 degree Kelvin or 0 degrees Celsius, and its pressure is 1 atmosphere or 101.3 kilopascals, and it also occupies a volume. 1 mole will occupy a volume of 22.4 liters. That is 1 mole of a gas at standard temperature and pressure. So now that we know these parameters, let's proceed into the next thing that we have. Let's talk about the mole and the molar volume of gases. It doesn't matter what type of gas it is, whether it's oxygen, hydrogen, carbon dioxide, hydrogen sulfide, whatever that gas is. If it is an ideal gas at the standard temperature and pressure, 1 mole of that gas will occupy 22.4 liters or 22.4 dmq. Whichever one you choose to use, it's perfectly fine. So think of it like this. If you fill a big party balloon, for example, with 1 mole of helium, helium is actually a gas, okay? A noble gas in chemistry. At standard temperature and pressure, that balloon will contain 22.4 liters of helium. So if I say oxygen, for instance, at standard temperature and pressure, it means the volume of 1 mole will be equal to 22.4 liters. The temperature will be 0 degrees Celsius or 273 degree Kelvin. And then the pressure, P, will be 1 atmosphere. So that's it for standard temperature and pressure conditions. So now, here is an easy conversion guide that will prove to be very helpful to you as we proceed and as we want to solve some questions. If you have number of moles, for instance, and you want to convert it into volume, right? And you want to find that volume in terms of liters. What you simply do is volume is equal to number of moles multiplied by 22.4. Because remember, 1 mole of a gas at standard temperature and pressure occupies 22.4 liters. So now if you have number of moles, let's say you have 2 moles of a gas, it will now occupy an unknown amount of volume. If we cross multiply, the amount of volume it will occupy will now be 2 moles, which is number of moles, times 22.4. And that proves this formula we have over here. Number of moles times 22.4. This is the number of moles, and this is 22.4. On the other hand, if you have volume and you want to convert it into number of moles, what you simply do is number of moles is equal to volume divided by 22.4. So let's say we have 220 centimeter cube and you want to convert this into number of moles. What you simply do is to divide it by 22.4 dm cube. And of course, this cm cube over here, you'd have to convert it to dm cube because all units must be uniform whenever you're dealing with calculations that involve units. Now that we've talked about that, let's see if we can solve some questions to consolidate your understanding on this subject. The first question says, how many liters will 3 moles of nitrogen gas occupy at standard temperature and pressure? So first things first, we know that at standard temperature and pressure, 1 mole of any gas occupies 22.4 liters. So now they are asking us 3 moles of nitrogen gas, how many liters will they occupy? So therefore 3 moles of nitrogen, N2, will now occupy X, since we don't know the volume it will occupy. So if we cross multiply over here, this becomes X times 1 is equal to 3 times 22.4. X multiplied by 1 is the same thing as X. 3 multiplied by 22.4 gives us 22.4 times 3 gives us 67.2 liters. So you can see how we've carried that out. So if 1 mole occupies 22.4, 3 moles of a gas will simply occupy 22.4 times 3, which is 67.2 liters. Is there any other example we can solve to consolidate our understanding? Yes, let's do the second example. Example number 2 says a gas has a volume of 44.8 liters at standard temperature and pressure. How many moles is this? So we know at STP, 1 mole of a gas occupies 22.4 liters. So they're asking us now that a gas has a volume of 44.8 liters. How many moles is this? So X moles will now occupy 44.8 liters. At this point, we can cross multiply. When we do, it now becomes 44 times 1 is equal to X times 22.4. 44 multiplied by 1 gives us 44. And then this becomes 22.4x. Okay, this is 44.8. I beg your pardon, 44.8. Notice over here, 44.8. So let's proceed. X now becomes 22.4. We divide both sides by 22.4. So this is 22.4. So when we say 44.8 divided by 22.4, that gives us 2. What's the unit now? Remember, we are looking for how many moles is this? So this becomes 2 moles. So you see how that was carried out. So let's move into the next thing that we want to talk about. So the next thing to do is just one more example. Example 3. It says if you filled 5 balloons with carbon dioxide gas at standard temperature and pressure STP, and each balloon holds 4.48 liters, how many moles of gas did you use in total? So the first thing we need to do is to know the total volume of gas that we have. How many balloons do we have? We have 5 balloons, right? And it was filled with carbon dioxide gas. Each balloon holds 4.48 liters. So one balloon holds 4.48 liters. So therefore 5 balloons will now hold X liters. So from here we can cross multiply. This becomes X times 1 is equal to 5 times 4.48. X times 1 gives us X. 5 times 4.48. 5 times 4.48 gives us 22.4. This is the total volume that we have, 22.4 liters. So now that we have the total volume, we can now convert it into number of moles. So remember, at STP, 1 mole of a gas occupies 22.4 liters. So now we have 22.4 liters over here. So X moles will now occupy 22.4 liters. We can cross multiply. If we do, this becomes 22.4 times 1 is equal to X times 22.4. This multiplied by 1 is same thing as 22.4. This is equal to 22.4x. We divide both sides by 22.4 to get x. This cancels this. 22.4 divided by 22.4 is basically 1 mole. So I'm sure you saw how the conversions were occurring, converting from volume to moles and from moles to volume. So here's a summary of everything you need to remember whenever we're talking about the mole concept and gases. 1 mole of any gas, first of all, occupies a volume of 22.4 liters at standard temperature and pressure. Standard temperature and pressure simply means that the temperature is 273 Kelvin or 0 degrees Celsius. The pressure is 1 atmosphere for the condition of STP, and we use it to convert moles to volume or from volume to moles, and this works best at STP. So now that we have said that, it's time to wrap up this video. But before we do, let's hand out some practice questions to each and every one of you who stuck around till this point. Okay, so we have 3 practice questions that I'd like you to try out your hands on and comment the answers in the comment section below. Question number 1 says, what volume will 0.25 moles of a gas occupy at STP? Question number 2 says, how many moles of a gas are in 89.6 liters at STP? And then question number 3 says, a balloon contains 11.2 liters of helium at STP. How many moles of helium are inside? So take your time, solve this question, drop them in the comment section, and I'd be more than willing to respond to each and every of your comments. So at this point, it's time to wrap up this video. I want to say a very big thank you for sticking around till this point. If you did, it means the world to me. So up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I will surely see you in the next video.